Why don't we go ahead and get started? I'm Mike Alexander. I'm with IBM. And Mathews Thomas is also from IBM. And we're going to go through a set of slides that we've got here that talk to some of the engagements and some of the networks, the blockchain networks that we've deployed. Not unique to any of the industries. It's cross-industry activities that we've done. And then we've got some demonstrations of some of the capabilities that we've built around some of the uses of blockchain for some of these industry problems. Right? So let's build it out. So we start with a slide that kind of touches the fact that blockchain has become prolific across our industries, right? And its use in industries. Specifically around, it started heavily with the financial industry. We then focused on the food safety with Walmart as one of the first more broad network implementations. It then went into aspects within governments, right? So we've done activities within different government segments for ports and travel, for their dealings of manifest and taxations and things like this. It actually moved into a broader activity that went across multiple ports with the trade winds type implementation. We've got partnerships with Sovereign on identity. And then what we bring from our standpoint is that we will support a customer who wants to become part of the Sovereign network. We can set up their node. We can basically sponsor them into the association. And then depending on how they want us to work with them, we'll even run their node for them as part of the Sovereign network. Right? We have then within other industries where we've looked at, so when I look at blockchain from, my background is telecoms and telecom industry, I look at it and I say, this is a business transformation capability. You have to think of this as a business transform, and what are the problems that you're trying to address within that transformation, and then what are going to be the values that are generated out of that transformation, right? Because you're looking for as was discussed yesterday in one of the other sessions, how do you sell this capability into a customer that says, why should I invest in this, right? And therefore, you have to be able to point to their problems, and we'll go through in the slides, we identify those. And then what are the results that can come out of the correction of those problems? And in each one of these use cases we're showing, we show you those aspects of how we took the problem statement and the situation, what then we work through as what would be achieved out of it, and then what actually gets achieved out of it, right? So we'll take Worldwire as one of the first ones, right? So Worldwire is a consortium network, a blockchain, which deals with the aspects of payment settlements between banks, right? And some of the government regulations that fall into place when you start to deal with transfers of money. How do you deal with the regulatory aspects of proving that the money was transferred, legally between the parties, was taxes basically received on those before payments were made, all of those aspects, right? So when we look at the business value, so problem statement is, I've got a lot of time and effort, to make a financial transaction between two parties and a banking situation, right? So we look at it and say, how do we deal with the support of payments between the parties, which has to be done where it's not only between the central banks, right? Because there was all that process between central banks that existed previously. To be able to deal with it on a scale, but also then deal with the regulations of each of the countries that you're dealing with financial institutions within them. So it was part of the sale to the banks is the fact that the regulatory requirements then are visible that you're achieving those for the regulators, right? And we see that in other situations when we look at other industries. The regulatory compliances are one of the key factors that you bring in because you get that transparency to show back to the regulator exactly how the compliances were met. Right? When we step to the next, it was in disputes resolution. So this was an internal IBM use case where when we looked at our financial institute, our own internal financial organization that finances large deals and capabilities within our customers, there was a significant amount of dispute funding held at the end of the month because you're sitting there with, did the actual goods get delivered? Were they, was there fallout of the goods? Was there damages on the goods? Did they meet the actual procurement that was supposed to have been of those goods? And it turns into in our case, $100 million a month issue, which you have lots of people dealing with, trying to deal with dispute resolutions and then final resolution with payments. So there was a significant amount of cash that was held every month in this aspect of dealing with disputes management. So it was first an internal process, right, of how we saw it as a way to reduce that cost of dealing with disputes within our own dealing or our own financial institutions. When you start to look at other industries, that same problem exists in almost any industry that has goods that they're acquiring and they have to deal with payments back for the goods, right? So it's the disputes resolution problem is not a single problem for one customer, right? An internal customer. It is a problem across all customers. And so that kind of global network in dispute resolution is another area that you look at and say, this is a common problem. Is there a way to standardize this type of blockchain capability in a network situation to deal with your suppliers and your original procurers of goods back and forth? And we see that, and we'll talk about that in specifics to how we see that, say, in the telecom industry, which has a significant amount of supply chain issues in their procurement of goods and to the final delivery, in some cases, to consumers, right? Handsets, things like this. Trusted identity. Sovereign's here, and we're part of that sovereign organization, foundation. We're one of the founding partners within it. And so identity is a problem that has been dealt with on a unique basis each time, right? So is there a way within a sovereign type implementation that you can globalize that kind of identity management with all of the requirements that identity have? So we had done other implementations with other identity partners. We did the one in Canada with a different partnership that provided the use of an identity system for dealing with the government aspects of identity. How do I create my identity that we use for passport identities? Well, and the same goes for driver's license or for the use of identity that's necessary in a commercial requirement of the bank. Are you when you set up your account? Or you when you go into set up your mobile number account, those types of things, right? So identity is a prolific thing, right? And the problem with identity becomes the management of who has access. So when you start to look at what the blockchain brings with its smart contract capabilities and the consensus of that contract of who, and for what reason that information is going to be exchanged. Therefore, you get that kind of control that says, I don't have to give anybody direct access to identity information. I can have that identity information held in an encrypted capability. Within the use of the smart contract, it extracts the information that's necessary for meeting that particular business requirement. It does not have to give your details of your personal information if what you're trying to say is, do you have income of a certain range? I don't have to tell exactly what your income is. I can give you back a yes or a no requirement that says you do have that kind of income, and never expose the details of that income to any of those parties. We use that, and we'll talk about it in a government situation within the India marketplace on how we protect identity of consumers to people who want to be able to direct targeted advertisements to specific segments within that community. And we're talking about billions of consumers in that marketplace, and how that methodology that we've used basically protects the consumer's information, but gives a business value to the use of their identity when they've consented to allow that identity to be used. Music royalties was another use case that came to us because that particular industry has a significant lag in payments to the original production of that music item, right? And it's not a simple one-to-one, right? Because what happens is when you create the piece of music, there's many parties that are part of that. And the agreement between those parties states how the split is made for royalties based off of that production. And so that then has to go downstream to when the music is consumed, and then you start to get into, yeah, but the payment of that consumption is tied to where it's being played. So now you start into each of the countries, what's their taxation rules. Now I'm making payments to you for that use in that country. So what are the taxation rules that I need to apply against that payment? What's the splits between the various parties? What's the government use cost of that? All of that becomes part of a very complex smart contract. We took that challenge and started to look at it and said, this is actually too complex for a smart contract. That we have to back it up to the origination of the contracts and therefore improve the simplification of that smart contract, so then downstream you're not having to deal with so many variabilities in the smart contract, which makes it a non-valued situation in trying to use one type of programming capability to solving a much broader problem that's not just a simple one-state capability that we're dealing with. It did prove the value to it. It's just that the complication of the contract was just too complex, right? So from my industry, on the telecom industry, one of the key problems has been fraud. Right? Roaming fraud for specifics. That when you arrive in a country, you can be identified at the airport that you're starting to roam in that country. Your identification of your phone number can then be picked up, transmitted, produced in a massive fashion, and all of a sudden your identity has been fraudulently populated in charges that are occurring to many different carriers at one time. So part of the aspects of dealing with that is how, when you basically are starting to roam within an environment, how do I go about authenticating that you are you in that roaming back with your home carrier who's actually going to receive the charges for your roaming? And so we looked at it and said that from that kind of standpoint, if we are creating a blockchain network between the major carriers who provide their roaming to their customers and the participants within their network of who is going to support those customers roaming. How can we use a blockchain capability to basically create that authentication that you were you? And we're starting to see it all the time now with the two-part authentications, right? That first thing is, okay, we recognize you're roaming. We'll send you an SMS message. That SMS message must be then responded to back to your home carrier who says, yes, that's me, I'm roaming there. And therefore, you immediately, the home carrier immediately sees the fact that you are there and that you are authenticated there. When we move to the newer 5G environments, the situation changes a little bit because no longer is the home carrier blind to where you're roaming, because part of the environment will be they will see the charges occurring as well as the roaming partner charges that are occurring on both sides. And so we start to see that kind of transparency occurring, right, that will allow some of that, the problems that we had previously with roaming and fraud to be alleviated. But now what we'll talk about later on is there's now, well, roaming is a little different now within a 5G environment. So how do we deal with the roaming payments between the partners? And we've basically partnered up with one company and deployed now a blockchain implementation for roaming settlements that has gone into production this year. Transparent ad supply. So again, this is about the aspects that you have a life cycle on an ad that basically needs to be managed against many parties. You have the originating party of the advertisement, then you have who is basically going to deliver those ads, and did they achieve the requirements that the advertisement had in its placement, the coverages, particular age segments that are being targeted, those types of things. So the problem has been lack of evidence that the advertisements are actually being delivered. This was a situation actually in Japan when they were doing the evaluation. They found there was a lot of fraud in the fact that people were claiming the ads had been delivered and that they had been successfully delivered, and there were millions and millions of dollars of fraud occurring because they actually had never been delivered, right? They never executed the campaigns. So part of the ad supply chain is about, I want to trace that capability of the origination of the ad, who created it, what were their requirements on that advertisement, did that advertisement get delivered? How do you verify that the advertisement gets delivered? So we have another example case where we take it to extending to that last piece, how we created a blockchain environment that was a compromise between both the Hyperledger function and the Ethereum functions, because we needed the two parts. We needed the public side so that we could get people to basically give us the response that said, yes, they had received that advertisement, what did they think about the advertisement, those types of things, to actually then be able to trace the fact that the ad was successful, the ad was targeted correctly, all of those aspects. And we have done that as another implementation using blockchain as that segment of this life cycle in advertisement. So these are three of the most recent ones. Cineverse is a company that basically did roaming settlements for about, I think, somewhere around 80% of the global carriers, right? I think it's something like $30 billion that they deal in settlements on roaming charges, right? So part of it was those systems really didn't give you transparency between the parties of when a roaming carrier was going to basically send their charges back to the home carrier for settlement. There was no verification that those charges were actually valid or not. It was yes, you could then post-process to determine that there was fraud, that those were not real charges. There was disputes between, oh, wait a minute, I never made that call when I was in India. To how can we get it to the point where within the smart contract functions of the blockchain, we use that as a way to first verify that the format of the data I'm going to act upon actually is valid. That I'm not going to have you submitted a file and it's no good, right? We have to have an agreement around the format between you and me on the format of that file and how it's going to be processed. Otherwise, I can't pay you until I get the correct format. So the smart contract is partly on the input side to verify the formats match. Then you have the aspects of, well, now what is in still dispute because I've got charges that say, wait a minute, he was in India, but I know he was in the US at the same time. Therefore, I'm going to dispute that charge as being a fraudulent charge. So I want a way to see that aspect of dispute and what has been held back in settlements. Because I know then I have potentially a residual price that I have to pay for, back to that original roaming partner. To the final aspect is I deal with the bank. I got to deal with the bank to actually settle between these two parties. So I want that part to also be visible on the blockchain. When was it submitted to the bank for settlement? How was taxes dealt with between the two parties? All of those aspects which you record within the blockchain so that you have that full life cycle view of that transaction between the two parties. From the original contractuals that we said, oh, you giving me a discount for those charges while he's roaming, I want to see that discount has been applied against those charges that you're creating that I owe you. And part of that was part of what we had to build into the smart contracts as part of that implementation with Cineverse. Media Ocean was that discussion I was talking about, and how do I verify that the ad campaign actually got delivered to the criteria that was put in place around a successful campaign. So again, that was where we combined a combination of Ethereum and the Hyperledger. Hyperledger really dealing with the back office environment, and Ethereum dealing with the consumer side of it for giving a public blockchain capability that everybody could interact with. The last is the aspect of the India marketplace, where we were asked to, first off, did we think blockchain could actually implement this capability of over 1 billion consumers that needed to basically manage the consent to who was going to be allowed to send them advertisements. It's kind of a do not disturb, where instead of you blocking everything, you say, oh, but I want to have advertisements only from my bank or from these particular enterprise types or specific companies who can send me specific advertisements. I will only receive those. But now I have to verify that they consented to it, that the advertisement that was then prepared never gave exposure of who it's going to go to, but it meets the criteria that was there demographics, was there specific in religion aspects dealt with as part of the selection of who to target those advertisements across the multiple carriers within the India marketplace. So on a daily basis, we're basically processing hundreds of millions of advertisements that are going to be sent through the messaging platforms of the carriers directly to their consumers without ever exposing who that person is. We never give them direct access to any of that information. We now have taken that as a capability, that whole consent aspect. And we will talk a little bit about how we now use that for other techniques, for other business requirements, such as we start to look at your home, right? What information do you want to expose from your home to third parties? How do you basically consent to that exposure of your information to those third parties? How do you protect the fact that nobody directly accesses that information unless you've given permission to them to access it for a specific requirement? Those are all part of what we see blockchain being the key part of managing that data accessibility and the rights to that data to be used within the consents that you manage as a consumer for not only your home aspects, but then when we look at businesses, there's aspects within businesses and what you do in information that from a business, you do in a B2B process of consenting certain information to be shared between the parties. So I'm going to turn it over now to, since I chewed up some of the time, to Mathews, and he'll go through some of the demos that, which I hate to use the word demo because these are not, these are in what I would say as minimally as proof of concepts, in some cases pilot capabilities that we've already built around some of these business problems.
Thanks, Mike. So what I'll do is give you a very high-level overview of a reference architecture that we use. Again, we could spend a whole days on this. And then there are two solution prototypes that we're planning on showing. I'm just looking at time. We may not have enough time. One is going to be around supply chain. The second one is going to be around 5G and how blockchain is being used in our solutions in those areas. Feel free, and I just mentioned the two because feel free after this meeting, if you'd like to get into any details on any of the ones that we were not able to show, to just ask us questions and we can show you the solutions. Like I said, we could spend a whole day on this architecture, but at the core of it is you've got blockchain, you have to have an integration layer, you've got a whole set of back-end systems you've got to integrate it, you've got to worry about access control, security monitoring, you've also got to figure out the placements from an infrastructure perspective. Is it running on the cloud? Is it local? Is it running on the edge? If it's on the edge, is it on an edge device? Or is it, in telco, we have something known as a MEC. Is it running on that? So there's a whole set of discussion that could happen around this, but I'll just quickly gloss through it, and let's go right into the first solution prototype that we were going to discuss. And this is around supply chain. I'll be showing you some of the key highlights of it, but I'd like to give you an overview. Within the telecom field, if someone places an order, there's a whole set of steps that need to happen. So the first party would be the B2B company that actually places the order. The next would be the telco coming and looking at that specific order. So we have some of the key parties here on the left-hand side and determine if that order can be fulfilled. The next would be the actual provider of the equipment. The next would be someone actually has to go there and do some installation. The next is, especially with the emerging of edge computing, right now most of the networking functions have now been virtualized. So you've got to get the VNFs or CNFs as we call them, depending on if it's virtual or containerized. Make sure you have the licenses and you get everything up and running. But once you have it running, you have to operate it. And operations causes a whole set of issues also that you can use blockchain for. First is the actual use of that service, because you may have a usage-based pricing. So every time someone uses that service, I'd like to have a clear entry that shows that individual actually used that service. Then there could be issues around security. Someone could tamper with some of the devices or the images. There could be issues around systems going up and down. The system goes up or down, that has a huge impact on you not having that service available and have those service level agreements been met. So that will be part of what I'll show. And then the last piece that we also have to address is, what about the actual consumer or user of that service? So in this specific case, we'll show an example of providing a service around a security system. But that actual user of that service is giving you data. And that user has the right to determine how that data is used, going back to what Mike had just said earlier. So that is all part of the full end-to-end supply chain that you have to consider when you integrate, when you develop a simple supply chain use case within the telco and media industry, telco industry. So the way it would work is, and I'm quickly just going to gloss through this. So, we've got some key players. These key players all have to interact with each other, and that's what this dashboard says. And this purpose of this was just to highlight just the sample of the players that are involved in this solution. But someone would come and place a specific order. So in this case, this individual is going ahead and placing an order for a smart system that does some security and other things. The order then gets decomposed. So these are all the back-end systems that need to be considered. And once the order gets decomposed, the order is made available. The individual who made the order, in this case, the enterprise customer, should be able to go onto a dashboard and confirm, yes, I actually placed the order. It was placed on this time, on this date, because there may be certain SLA agreements that need to be followed. And then once that order is placed, what has to happen is all these different parties have to collaborate. And I'll just be glossing over this really quickly, but some of the things that need to happen, for example, would be the equipment provider has to look and see, hey, do I have the equipment? The equipment provider may not have met the SLA for that because they were supposed to provide at a given point in time. And you get the drill. Licenses need to be acquired. If I don't have the VNF for that specific or inventory for whatever it is, I need to make sure all of that is made available. So we have this interaction between all the parties to ensure that this is actually available and possible. And then what happens is, at some point, and in our specific case, we just show an IoT device, okay? The device is available and it turns on. Now, but that's not sufficient. All that we've done is we've talked about the equipment that's going to be on-prem. What happens on the back end? On the back end is there's a whole set, at least from a telecom perspective, there's a whole set of, and by the way, there are licenses and a whole bunch of other things that need to be taken care of. There's a whole set of services that need to be run. You need to bring up your VNF. So what we're showing over here is the VNFs actually being brought up related to the specific service.
So part of what is what you're seeing is information that's coming actually from the blockchain, right? Because we're recording all of those state changes that are occurring in the order from origination through this life cycle of updates that are occurring to the final aspect that the service is now active for the customer. And that's all being recorded within the blockchain, right? So that then, again, as Mathews is saying, different personas have different accessibility to the information, right? That I want to see if I'm field force, what are the orders that I need to be able to, direct my staff to go out to the field to basically do an install or some other aspect of service within that particular order. So I want to see all those. And that's part of what you see from that persona or that, part of the process, right? That's being all recorded within the blockchain.
Thanks, Mike. And you see the little text at the bottom? That's the actual records going into blockchain. And every time a little box appears, it means something happens on blockchain. And if you're interested, we could actually go into the blockchain system and show the actual transactions being recorded. So once the VNFs have been made available, the next step is the service is up and running. We actually have to go and show the usage of that service. And every time that service is used, a transaction can potentially occur in blockchain. So what you see over here is we're actually using the service. We're just simulating a doorbell or something ringing. And as soon as that service is rung, you'll notice that a call is made. You probably saw that window just right up there, just displaying a call being made. And then all those transactions are again being recorded in blockchain. And then what happens is, okay, great, so everything appears to be working fine, but no. There's a whole set of additional issues you need to worry about. So let's suppose someone goes and tampers with the device. Our policies prohibit a USB being attached to the device. So someone goes and starts tampering with that device. Once again, we have to disable that. Transaction gets placed in blockchain. The supplier, et cetera, all need to be notified. We may have to go and change the system depending on the extent of the violation. And then we can continue on and show, additional examples where the actual VNFs are being tampered. So right now we've just talked about tampering that's occurring at on site. But what if something happens on your cloud or something else, and you have to address those issues also. So we can go ahead in this specific case, and we have a policy, for example, that you cannot do certain things to a VNF running in your infrastructure. But someone goes ahead and does that. We're able to detect that. The moment we're able to detect that, it could require a completely new VNF being provisioned. It could be required something coming from the customer. There's a whole set of additional things that need to happen. And then finally, we have a whole set of additional cases here that all require blockchain to get that full, transparent view to all the parties involved as to what services were being run, how they were being run. And if I'm charging you for something, I can actually prove to you that this customer used this for the service. And if your service did not meet my SLA obligations, I can prove to you that that specific service stopped at this point in time, and we had to restart it again. 2 hours later, I lost X amount of revenue because you could not fulfill those requirements. I'll quickly show one more thing, and then just back to what Mike said, because we've so far only talked about this from the perspective of the interactions between all the parties to make sure the service is available. What about the consumer of that service? So the consumer of that service also is part of this ecosystem. And what's key to that consumer of that service is data. You, telco, have access to all this data that belongs to me, and you're going to monetize it. I have the right to determine who has access to that data, when they have access to that data, and if I decide to switch this flip switch and prohibit access to it, I need to have that right. So once again, we use blockchain for that, where we have, so here's a consumer with all these devices. This is what the world's going to look like if it isn't already, okay? Who has access to all this data? And we're using blockchain to manage that. So the idea would be the consumer could go, look at all the devices that they have in their environment. They could go ahead and select specific access rights. So here's what we're showing, specific, who has access to my video, who has access to my temperature, who has access to everything else. Make that available, and then there'll basically be an interaction between those who would like access to the data and the CSP to determine if that data can be given, what the terms and conditions are, all being recorded in the ledger. I know we're pretty much almost out of time, but we definitely want to leave a few minutes for questions. And like I said, we also have another solution that we could, for those interested, that shows how we're using blockchain within the 5G environment.
And part of the challenge that was put to us by one of our customers was, can it scale? Right? And that was part of what we had to prove in the India marketplace, which is in production, that the systems, yes, if you engineer it right, you can scale, right? To the billion type, numbers. And so it isn't a scale issue, it's an engineering question of how and what you're going to basically give accessibility to.
Okay, any questions? If not, we'll be around. Feel free to ask us. And if you'd like to see any of the other work, just let us know. Go ahead.
I guess I just have one quick question on the Indian telecom example. You gave really interesting kind of in a world of who owns that data, whether we own our own data or not. And when do you foresee, and that's the golden question, but when do you foresee that capability becomes more mainstream where
So I think there's somebody who just is getting penalized by the government because they've potentially exposed data, right? Data that should have been consented against. So the California legislation that just went into place. You look at the European legislation that's already in place. I mean, the penalties are very, very expensive if you can't prove the traceability of consent and the use of that data, right? And so it isn't going to be a question that you can not do it. You're going to have to do it. It's the question of what's going to be the technique. Are you going to try? So when we looked at the concern with virtual networks when we started talking to the telcos, right, was not the fact that, you know, the technology can work. It was how are they going to protect it? How are they going to use this, you know, be able to prove that the security hasn't been compromised? Because the stuff can just be spun up so fast and somebody can go in and make a change. Well, how do you, and it could be a valid change. Somebody goes in and they're debugging some problem, right? And they make a change, admin change, which worked okay because it was on the customer premise. But all of a sudden, the network changed and they moved it out of the premise to the cloud, right? And as soon as it moved into the cloud, it exposed it so that now other people can access that data that's coming, that's no longer firewalled out. And so the security folks look at and say, that traceability is a mandatory for them because the technology has changed so that it is so flexible, but they don't have the controls around it. And therefore the traceability is to protect them from lawsuits. Just like the protecting, if you have customer data, how are you going? We've always had PCI type information, internal, right? And you could do traceability and all. But now that data is being used outside of those enterprise systems. And you still need to be able to trace that. So in the case that I'm a carrier, I have, say, Samsung providing me their home gateway that I'm reselling to my consumers. How do I, Samsung is the entity that owns that home gateway. It's they're basically getting the information. So how do I assure the fact that that third party who's providing me as an OEM, their capabilities that I'm supplying to my customers, that the information is being protected all through that process? And that's where we see it and say, hey, we can do this with a blockchain type capability.
And what about kind of fast forwarding, maybe combining the digital advertising slide there? I mean, there's a plausible scenario here where I actually own my own data, and if you want to advertise to me,
right,
you're going to pay me for that. Right?
That's right. And what we start to see is, and the way we've suggested is, because we're recording these things, that record could have been a micropayment, right, that you're receiving, right, as part of that. You're part of a group that, and I'll give you a particular charge against or use, or I'll give you a token against those types of things. But yes, it's going to move to that. In fact, I think there's already apps out there that are starting to do that, right?
I think we're out of time.
I know you touched on it earlier, but in a more general sense, how do you see sort of these private deployments interfacing with the public blockchains like Ethereum that are like really consumer focused, whereas like enterprises would rely on these sort of private ones? And how do you foresee that sort of semi-permeable membrane moving forward?
So, I mean, even within the Hyperledger, there's work going on between the two parties, right, with Ethereum and Hyperledger on some of that. How do we interoperate between each other? Again, different technology for different requirements, right? Again, it became just what we did was we used the right technology for the right part of the problem statement, right? And I think that's going to carry on. It would be a lot simpler if we have well-defined interfaces between the two parties versus having to do something as a middle ground between us, right? So I think those will make it even more acceptable, where we have public blockchain networks that then need to interact with the enterprise networks, and that they will be a well-standardized set of interfaces and agreements on the information that can be exchanged and how it's exchanged, so that we don't lose that traceability from the one to the other, right? Which is key for the kind of information that we're seeing, going through those parties, right?
I think the next team's coming
Yep.
here, so.
Thank you.
Thank you very much.